Let N1 and N2 represent the numbers of claims submitted to a life insurance company in April and May, respectively. The joint PMF of N1 and N2 is given below. Calculate the expected number of claims that will be submitted to the company in May, given that exactly 2 claims were submitted in April. So we have to find the expected value of N2 given N1 equals 2. Now, before doing this problem, we will talk about another distribution about which we haven't yet talked in this course, and that is the geometric distribution, and you will see towards the end why that is so important. So the geometric distribution is basically a distribution which gives the probability of the first success requiring k independent trials, with each success probability being p. The PMF of the geometric distribution is f of k equals p 1 minus p to the k minus 1. So for this problem, we don't really need to understand what geometric distribution is. What we need to know is that the PMF of a geometric distribution is p 1 minus p to the k minus 1. And it's very easy to see why this will be the PMF, because we are finding the probability that the first success requires k trials. So if p is the probability of success, then since the first success is occurring on the kth trial, the first k minus 1 trials are failures. So the first k minus 1 trials would be 1 minus p, 1 minus p, 1 minus p, and there are k minus 1 of them, and then there's a success on the kth trial. Now, another thing to remember is that the mean or the expected value of geometric distribution is 1 over p. So once you know these two things, that a geometric distribution looks like p times 1 minus p power k minus 1, f of k, and its mean is 1 over p, we will see that it becomes extremely easy to do this problem, relatively speaking. So now, as we said, we are asked to find expected value of N2 given N1 equals 2, because N1 was the claims in April. So we are given that 2 claims were submitted in April. So N1 equals 2 is given. And we have to find the expected value of the claims in May, which is N2. So to find this expected value, we need the corresponding probability of N2 given N1 equals 2, or the corresponding PMF. So we use our basic formula. We know that probability of N2 given N1 equals 2 will be probability N2 is N2 and N1 is 2. So that means the probability N1 2 and N2 is N2. And we write it like this because the way the PMF is given to us, the first argument is N1, second argument is N2. And we are trying to write N1, N2 is equal to N2, and N1 is equal to 2. So that's what is saying that N1 is equal to 2 and N2 is equal to N2. And then in the denominator, you have the given thing, which is probability of N1 equals 2. So probability of 2 comma N2 will be obtained by substituting N1 equals 2 in the PMF and keeping the N2 as it is. So when you substitute N1 equals 2, you get 3/4, and this becomes 1/4 power 2 minus 1, which is 1/4 power 1. So you get 3/4 times 1/4. 3/4 times 1/4, and then n1 is 2, so you get e power minus 2, and this is 1 minus e power minus 2, and this stays as n2 minus 1. So e to the minus 2, 1 minus e to the negative 2, and n2 minus 1. And I've just kept the denominator as it is because this requires more calculation, so I will do this separately. So now let's see what the denominator will be. So when you have to find probability n1 equals 2 in the joint PMF, it means you will keep n1 equals 2 and you will sum over all the values of n2. If it's discrete, then you sum. If it's continuous, then you integrate. So here we will sum over all the values of n2, keeping n1 equals 2. And we've already seen that when you do n1 equals 2, you got this expression, the one in the numerator. And now this expression needs to be summed over all the values of n2. So now we're summing this expression over all the values of n2, and n2 goes from 1 to 3 and so on. So the 3/4, 1/4, and e to the negative 2, 3/4 times 1/4 is 3/16, and e to the negative 2, all this is constant, so I pull this out. And I have something with a power, summation power sitting on it, and that is a geometric series. So all you have to see is what's the first term and what's the ratio. The ratio is the base here, which is 1 minus e to the negative 2. And the first term can be seen by substituting n2 equals 1 in this. So when you do n2 equals 1, this power becomes 0, so it's 1. Anything power 0 is 1. So the first term is 1, and the ratio is 1 minus e to the negative 2. And then we know that the sum of infinite series is first term divided by 1 minus the ratio. So first term is 1 divided by 1 minus the ratio. And 1 minus 1 plus e squared, the ones cancel out and you just get e to the negative 2. That cancels with this e to the negative 2, and that's just 3/16. So the denominator is just 3/16. So when you divide this equation with 3/16, this cancels out this 3/16 over here, and you are just left with e negative 2, 1 minus e negative 2 power n2 minus 1. But now we recognize this as geometric series. Remember, geometric series was p, 1 minus p to the k minus 1. F of k equals p, 1 minus p to the k minus 1. Here we have e to the minus 2, 1 minus e to the negative 2 to the n2 minus 1. So e to the minus 2 is playing the role of p, and n2 is playing the role of k. Remember, this is a function of n2 only because we are holding n1 as fixed at 2. So we recognize this as the PMF of a geometric distribution with p e to the negative 2. And then we said that the mean or the expected value of geometric distribution is 1 over p. So in this case, it will be 1 over e to the negative 2, which is just e squared. And that is the expected value we needed. We needed the expected value corresponding to of this PMF. And that was e squared is choice E.